Let us start CBSE Mathematics Class 10th, Chapter 6. You see the theorem 6.7. If a perpendicular is drawn from the vertex of a right angle of a right triangle to the hypotenuse, then the triangle on both the sides of the perpendicular are similar to the whole triangle and to each other. You see, ABC is a right angle triangle where angle B is 90 degree. So AC will be the hypotenuse. From the point B means vertex, there is a perpendicular drawn to the side BAC, that is hypotenuse. So BD is the perpendicular drawn from the vertex B to the side D. So we have to prove that the bigger one triangle, that is ABC, is similar to the two triangles to each other. Means the two triangles means the ABD and BDC and ABC. These three triangles are similar. You see, I have written here, first of all, the triangle ABC, where angle B is 90 degree. Second triangle is, that is ADB. So angle D is 90 degree. Third, that is BDC. That is where D is 90 degree again here. So 90 degree is in the ADB and BDC. So this 90 degree is coming as, that is why they are right angle triangle again. But side by side you see the complementary angle of A in the bigger one triangle. The complementary angle of A is C. And what will be the complementary angle of C? That is A. So in this triangle, now you see that ADB. Here D is the 90 degree, therefore the angle A and angle this is also complementary angle. Means angle ABD and angle BAD are complementary angles. So we are getting that angle A has got two complementary angles, that is C as well as this point, means ABD. So that is why I have written here C. Means this angle will be equal to C angle. Similarly in this case also, for C the complementary angle is A, and for C in this triangle, in this right angle triangle, means BDC, again this angle is, and this angle is complementary angle. So the angle C has got two complementary angles, that is A as well as this angle DBC. So that is why I have written here A. So let us proceed further. If a perpendicular is drawn from the vertex of the right angle of a right triangle to the hypotenuse, then the triangles on both the sides of the perpendicular are similar to the whole triangle and to each other. Means there are three triangles, that is first, second and third. So these three triangles are similar to each other. Now proceed to the question, theorem number 6.8. In a right angle triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. To prove the AC square is equal to AB square plus BC square. Proof: in triangle ABC, the bigger one, ABC, triangle ADB, and triangle BDC. You see, I have written the name of the triangles here 1-1 correspondence. All these triangles are right triangles. In any right triangles, the remaining two acute angles are complementary angles to each other. You see, in details I have written here that angle A plus angle C is 90-degree complementary angle in the triangle ABC. Angle A plus angle ABD is 90-degree complementary angles in triangle ADB. Therefore, angle ABD is equal to angle C. So C plus angle A is 90-degree complementary angles in the triangle ABC and BDC. C plus angle CBD is equal to 90-degree. Therefore, angle A is equal to CBD. Hence, the above three right angle triangles, ABC and ADB and BDC, are similar to each other. Therefore, their corresponding sides are proportional. Once the sides are proportional, we can just write it in the proportionate form in triangle ABC and triangle ADB. AB upon AC is equal to AD upon AB. Just cross multiply it, you will get AB square is equal to AC into AD. You see, in bracket I have written sin C. Means if you take the sine of C means sine of C, then you will get the same result here. It is the ratio of that. In triangle ABC and triangle BDC, the BC by AC is equal to CD by BC. That is equal to BC square equal to AC into CD. This is the second. For this, to remember it, which side should be taken. So I have written here cos of C. In these two triangles, if you take the value or ratio of cos of C, then you will get this result, BC upon AC and CD upon BC. So just cross multiply it, you will get BC square is equal to AC into CD. Now adding first and second, we have AB square plus BC square is equal to AC into AD plus AC into CD. You take out AC common from these two places, you will get in the bracket AD plus CD. That will be equal to AC into AC. Again you will get AB square is equal to AB square plus BC square is equal to AC square. And it was the theorem of the Pythagoras theorem which has been proved. For more in details knowledge or to overcome your ambiguity, in first triangle, that is the bigger one triangle which I have given the name first triangle, second triangle and third triangle. You see, I have taken the sine of C in the first triangle, that is AB upon AC. Sine of C in the second triangle, I have taken AD upon AB. Now sine C, both, so this should be equal proportional. So just cross multiply it, you will get AB square equal to AC into AD. That will be equal to AB square. And the second one, in the second case, the first triangle is taken and the third triangle is taken here. I have taken the cos of C. So BC upon AC and cos of C in the third triangle, that is CD upon BC. Cross multiply it because both are the equal. They are the ratio for the cos of C angle. So BC square will be equal to AC into CD. So just to multiply it, you see, AB square plus BC square will be AC into AD plus CD. You will get again AC, so it will become AC square. Either you can remember this also, I have stated in the geometrical form also. With the help of trigonometry, you can just remember that which side you should take. Now in the first triangle, if you are taking sine of A, means BC upon AC. Sine of A means in the first triangle, if you take sine of A, it will be BC upon AC, and Leave the second one, come to the third, sine of A will be equal to CD upon BC. Now cross multiply it, BC upon AC will be equal to CD upon BC. Just cross multiply it, you will get BC square is equal to AC into CD. Final result will be, you just cos of A, again you take the cos of A in first triangle, that is AB upon AC, and second triangle number second, that is cos of A will be equal to AD upon AB. Now both are equal, so cross multiply, you will get AB square and AC into AD. Now adding these two, you will get here BC square plus AB square, again you will get AC square. Now proceed from exercise 6.5. Before proceeding it, I would like to tell you how to find the Pythagorean triplet. You see, 3, 4, 5 means square of 3 plus square of 4, that is 9 plus 16 is equal to 25. What will be the square of 5? That is 25. So just if you want to number of triplet, Pythagorean triplet, you just multiply it with the 2, you will get 6, 8, 10. If you multiply it 3, 4, 5 by 3, so you will get 9, 12, 15. If you multiply it by 6, you will get 18, 24, 30. Like so on, you can get from this. This is one of the method to find the Pythagorean triplet. Now, if you are having the even small number of any side, and that number is even number, at that time what we will have to do, let 6 is given the measure of the one side, so divide it by 2, that will come to 3. Now you take the square of 3, that will be 9. Now from here, what you do, that you subtract 1 and add 1. While you subtract 1, you will get 8. While you will add 1, you will get 10. Similarly, if you take 8, so divide it by 2, you will get 4. Take the square of 4, that will be 16. From 16, you have to minus 1 and add 1. Subtract 1 and add 1. While you subtract it, you will get 15 and 17. 15, and while you will add it, you will get 17. So 8, 15 and 17. This is your Pythagorean triplet. If you are having 10, so 10 divided by 2. 10 divided by 2 will be equal to 5. Take the square of 5, that will be the 25. Now subtract 1, add 1. While you subtract 1, you will get 24. While add it, you will get 26. So you have got Pythagorean triplet, that is 10, 24, 26. Now proceed, let the number is 12. So 12 divided by 2, you will get 6. Take the square of 6, that is 36. Now subtract 1, add 1. You will get 35 and 37. So the 12, 35 and 37. This is your other set of Pythagorean triplet. Now this was the case with the even number. Now if you are having the odd small number, so let 5 be the small odd number. So what you do here, that you just take the square of it, means 5 square, that is 25, divided by 2, you will get 12.5. Now what you do, that you just add 0.5 and subtract 0.5. While add 5.5, you will get 13. While subtract 0.5, you will get 12. So in this way, you will get 5, 12, 13. This will be the Pythagorean triplet. Now take the example for 7. So what will be the square of 7? That is 49. Divided by 2, that is 24.5. Now in one case you leave the 0.5 and add 0.5. So while you will leave it or subtract 0.5, you will get 24. While you will add 5.5, you will get 25. So 7, 24, 25. Now take 9. So 9 square. So it will be 81. Divided by 2, you will get 40.5. So what you do that you subtract 0.5 and add 0.5. So you will get 40 and 41. So the Pythagorean triplet will be 9, 40, 41. For further reinforcement of knowledge regarding the Pythagorean triplet, you see I have made a right angle triangle in which I have written here the 2m, m square minus 1, m square plus 1. This is the hypotenuse. These are the two legs of the right angle triangle. So if you just square it, 2m square plus m square minus 1 whole square is equal to m square plus 1 whole square. You will get 4m square plus m raised to power 4 plus 1 minus 2m square is equal to m raised to power 4 plus 2m square plus 1. Here you see m raised to power 4 to this side, m raised to power 4 to this side also. 2m square plus 1 plus 1. So left hand side is equal to right hand side. Means one side you have added the square of the legs and that is equal to the square of the hypotenuse. Now question number 1 of this same exercise, proceed. Whether they are the Pythagorean triplet or not. They have asked this question. You see, I read it. Question number 1. Side of triangles are given below. Determine which of them are right angle triangles. In case of a right triangle, write the length of its hypotenuse. You have to identify which will be the length of what will be the length of the hypotenuse. This is a 7, 24, 25. Yes, it is a right angle triangle. Because why? You take the square of 7, that is 49. Divided by 2, it will be 24.5. So leave the 0.5 and add 0.5. You will get this 24 and 25. So yes, it is a right angle triangle. Now come to this 3, 8 and 6. So square of the two small numbers, that is 3 and 6, it will be 9 and this will be 36. What will be the square of this? This will be the 64. So 36 plus 9, that will be 45. 45 is not equal to 64. Hence it is not a right triangle. Now proceed to 50, 80 and 100. No, it is not a right angle triangle because the sum of the squares of the small two sides, that is 50 plus 80, is not equal to the square of the 100. Now come to this 13, 12 and 5. So what is the small number? That is 5. Take the square of the 5, that will 12.5. Again you just subtract 0.5, you will get 12. Add 0.5, you will get 13. So yes, it is a right angle triangle. Now the question number 2, the PQR is a triangle right angled at P and M is a point on the QR such that PM is perpendicular to QR, so that PM square is equal to QM into MR. You see, in triangle PQR, angle P is 90 degree. So angle Q plus angle R is equal to 90. Means the remaining two. This is the 90 degree, already it is given. So remaining two acute angles, they are complementary angles. In triangle QMP, angle M is 90 degree. Therefore, angle Q plus QPM, QPM is again 90-degree complementary angles. Therefore, QPM is equal to R. Here just if you compare the Q here, so for the same angle Q, these two angles are complementary angle. Therefore, angle QPM and angle R are equal. That is why I have written inside it the angle R. Hence, the triangle QPR and triangle QMP and triangle PMR are similar triangles by angle criteria, or you can say triple angle criteria of similar triangles. Now in triangle QMP and triangle PMR, corresponding sides are proportional. So QM upon PM is equal to PM upon RM. So just cross multiply it, you will get PM square into is equal to QM into MR. Hence it is proved. Now proceed to the question number 3. Question number 3 states that in figure ABD, the triangle, a triangle right angled at A and AC is perpendicular to BD, so that AB square is equal to BC into BD. First question. Second is AC square is equal to BC into DC. And third is AD square is equal to BD into CD. So first question is this here, you see. Again I have written first, second and third triangle. Though I have written the name of the triangle is ABD, CAD and CBA. All are the similar triangles. Therefore, as per our requirement, I have written here the AB upon CB. You see, from first and the second triangle. First, bigger one, and second, this one. So AB upon CB will be equal to BD upon AB. Cross multiply it, you will get AB square is equal to BC into BD. Now, second part of it. AC by BC is third and second triangle. Third and second triangle. That is CAD and CBA. AC upon BC. AC upon BC. AC upon BC. You see the number. AC means second and first. Here also second and first letter. So AC upon BC is equal to DC upon AC. You see the DC means third, first. Here AC. So DC upon AC, cross multiply it, you will get AC square is equal to BC into DC, proved. Now the third part of it, again here I have taken the two triangles, that is ABD and CAD. Cross multiply it, you will get AD square equal to BD into CD, and it was to be proved, hence it is proved here. Now question number 4. ABC is an isosceles triangle right angle at C. Prove that AB square is equal to twice of AC square. So you see, in triangle ABC, angle C is 90 degree, as well as AC is equal to BC because it is an isosceles right angle triangle. Given that because isosceles right angle triangle. So angle B is equal to angle A, and that will be equal to 45 degree. So AB is the hypotenuse. According to the Pythagoras theorem, we have AB square is equal to AC square plus BC square. Here what I have done, that in place of BC I have written AC, it is already given. So AC square plus AC square. So AB square will be equal to twice of AC square. Hence it is proved. Now proceed to the question number 5. ABC is an isosceles triangle with AC is equal to BC. If AB square is equal to twice AC square, prove that ABC is a right triangle. You see, AC is equal to BC, it is given. If AB square is equal to twice of AC square, it is also given. So what I have done, that twice AC square, I have written AC square plus AC square. And once it is given that AC is equal to BC, I have replaced AC by BC. So AB square is equal to AC square plus BC square. Now according to the theorem 6.9, that is the converse of Pythagoras theorem, means the sum of the squares of two sides is equal to the square of third side. Means the angle opposite to the AB will be 90 degree. Here you see, according to the theorem of 6.9, ABC is right angle triangle. Hence it is also proved. Now proceed to the question number 6. Question number 6 states that ABC is an equilateral triangle of the side 2A. Find each of its altitudes. We have to find the altitudes, and it is an equilateral triangle having a side 2A, 2A, 2A. So AD is perpendicular to BC. ABC is an equilateral triangle. AD square is equal to AB square minus BD square. AD square is equal to AB square minus BD square. So in place of AB square, I have written twice of A whole square, and BD will be the half. Means 2A divided by 2 will be equal to A. So I have written here A. So 2A square minus A square equal to 4A square minus A square, that will be equal to 3A square. So we have to find the AD, this median. That is, AD will be equal to A root 3. It will be median also, it will be altitude also in the case of equilateral triangle. While it is an equilateral triangle, in that case only medians and altitudes are same. Now proceed to the question number 7. Prove that the sum of the squares of the sides of a rhombus is equal to the sum of the squares of the diagonal. Here I have drawn a figure that is ABCD is a rhombus. We have to prove that AB square plus BC square plus CD square plus DA square, means sum of the squares of the sides is equal to the sum of the squares of the diagonal. We have to prove it. As we know that the sum of the squares of two sides of a triangle is equal to twice the sum of the squares of the median bisecting the third side and half the third side. I read this again because this theorem is known as Apollonius theorem. As we know that the sum of the squares of the two sides of the triangle is equal to the twice the sum of the squares of the median bisecting the third side and half the third side. You see, in triangle ABC, I have written ABC, BO is the median, as AO is equal to OC. means O is the midpoint of AC. So AB square plus BC square is equal to be twice BO square plus twice AO square. That Apollonius theorem means sum of the squares of the two sides is equal to the twice the square of the median, means BO, and twice the square of the half of the side, means AO, third side, half. So similarly in the case of ADC also, you see ADC, the second part I have taken separately. So here AO is equal to OC. So again applying the Apollonius theorem, AD square plus DC square is equal to twice DO square plus twice CO square. That is second part of the equation. Now adding first and second, we have AB square plus BC square plus CD square plus DA square is equal to twice BO square plus twice AO square plus twice DO square plus twice CO square. You see, these are the sides of the rhombus. Now come to this side. Here you see the 2 is common everywhere. So I have taken 2 outside. BO square, DO square, CO square, AO square. Now again, if you see the BO is equal to OD or DO. So that is why in combining these two I have written twice BO square. CO and AO, these are two equal, means diagonal bisect each other. That is why I have taken twice of AO square. Now while you insert 2 inside, you will get 4 BO square plus 4 AO square. Now that 4 BO square I have written twice BO square plus twice AO square. Again for twice BO I have written BD. Means BO is the half of the BD. So twice of BO will be equal to BD. So it will be BD square. Again here also twice of AO will be equal to AC. So AC square. Now these are the BD and AC. These are the diagonal of the rhombus. So the sum of the sides, sum of the squares of the sides of a rhombus is equal to the sum of the squares of the diagonal. Hence it is proved.